We're going to talk about key elements. We're going to look forward discussing ambitions and actions which will rely to facilitate the success and moving to a healthy environment. Let's start with M- Engineer Mr. Ahmed Al-Na'mi. Welcome to this session. You are a master's holder. Sorry.
You are a general manager of geologistics program in the kingdom, and also you supervise the national greening program. You have a wonderful CV, Dr. Ahmed Salah, as well.
Resources engineering. You are an international water resource engineering and geospatial tool expert with 29 years of expertise. So we would like to use those years of expertise here today in this session for sure. Dr. Ronald Vargas, you are a agronomy engineer with expertise on soil, land health. You worked as a researcher, lecturer, consultant, technical officer in various organizations as well. So I believe this session will be really, really fruitful, hopefully. Now, I know you gentlemen have presentations for us today. So let's go ahead and start with you. انجينير أحمد تفضل عندك عرض مرئي لنا اليوم. الكليكر بليز.
بسم الله الرحمن الرحيم.
تحتاج الكليكر صح؟
كيف؟
تحتاج الكليكر للبرزنتيشن؟
لا في الأخوان
أوكي تمام.
معي هناك ما يقصرون.
يلا تفضل.
With his presentation. And of course, regarding and in relevance with the greening projects, whether from public sector, private sector, or even non-governmental organizations or individuals, there must be a platform that consolidates and also support the efforts in order to have this platform help us in counting the trees that have been planted and as well the preventive and prevention and the protection efforts as well. I'm going to share with you the platform that is going to be launched next month on phases. The first phase is going to tackle the private and public sector. Second is going to be open to an open source to the public. The platform that is going to be launched next month is going to be a national platform to share data and information and also organize efforts and also guidelines in order to facilitate the greening programs. There are many activities related to seeding, bank seeds, seed banks, and also collecting these sands and preserving them. And as well as, of course, activities related to the production and greening programs and activities. We have the care and the protection, of course, activities that are also provided on the platform. The citizen, resident, or the entity could have a contribution, whether in the seeding or the greening or the activities related to the production. Of course, this platform is also unique because it gives a unique goal for each entity, and each entity would have the opportunity to access the platform with a designated username and password and designated profile. It could log onto the platform and also share the activities that they contribute in the greening programs. The goals are going to be clearly showed, and also progress is going to be evidently shown. Of course, we have the governmental and ministerial entities. We have later on the construction of this platform in order for us to reach the level that it is open as an open source to citizens and individuals. These are the different activities we have. If you click on any of the activities, they would clarify, these guidelines would clarify which plant species are planted in which areas. These guidelines are going to be all right. Each area has a different species of plants, also irrigation system, also the planting, the way our method of planting itself is going to be mentioned in the guideline. The contributor is going to log in. It could be a contribution, or the shareholder is going to contribute publicly in an area, and each area is going to be demonstrated, and the different activities are going to be shown in each region or of course area, and the shareholder or the contributor is going to be able to indicate the time and date of the contribution. This platform also enables the contributors to contribute in activities of the public sector. We facilitate the registration, so through jotting down the information, they could also manage the activities individually. Now the contributions, each contributor would have, each entity would have a dashboard that is dedicated to it, and also we could the progress is going to be shown as well. Also the tools that they could use, such as artificial intelligence and remote sensing, and we are going to tackle some of the tools. This is in Najran, Najran city. There is a planting program, and he's going to also manage the progress over time. This is a greening program that happened in Najjar, and there is a comparison between two different times. We could use this tool as well in order to know the number of trees that have been planted. These are integrated with, this tool is integrated with artificial intelligence. So it gives us a timeline for the growth of the plant. Yes, we can see the growth rate of the plant, whether it grows slowly, or in Arar, for example, there is plant species that grow really slowly, or it takes time to grow, and other plants are faster to grow. So we also could detect the health of the plant species and trees, whether if we could visit the area and also interfere in the process of growth of the trees. Also, it is open or it is accessible in order to I want to go into detail. For example, the platform allows you to upload drone pictures, upload drone pictures and data, also irrigation systems, any assets or gaps or holes in the area. They could upload pictures from drone on the platform, and we could provide the tools for them in order to enable them. Yes, of course, we enable them to use the tools through the platform in order to manage. I think this platform is going to increase credibility and give us transparency regarding the number of trees that have been planted. So this is, in a nutshell, the platform that is going to be launched next month. Thank you, Engineer Ahmed. And maybe I would like to add a comment, which is it gives them a motivation. You enable them since they could see for themselves the progress that is happening on real time. Yes, of course, and increase competitiveness as well. Dr. Ahmed, سوف أنتقل لك الآن.
Your presentation, and then we'll continue. There you go.
Thank you. We're waiting for the slideshow here to start.
It will start in just a moment. So, Dr. Ahmed, tell me more about your involvement in these projects until your presentation starts. When it comes to ambition and action, translating ambition to action, what is the key factors to succeeding in that transition to action?
Thank you. Yes, assalamu alaikum jami'an. طبعا the first thing to share here is just to use one path and continue on that path. And that's specifically what we used to call in the past 2.5 years the glue, using geospatial technologies from the start to finish, from seeding to monitoring the plant. And geospatial technologies would help on this, and actually had helped us in this path that hopefully we can actually share with you here in a little bit. There it comes. So maybe I can answer the question through the presentation.
Please.
It will be focusing on a concept that we have used here. Is called the suitability modeling. Basically, it's two sides of the same coin, like what would be the right tree for the location, and what would be the right location for each tree species. The project was actually divided into different action zones, as you can see here, and that is the national parks that we'll be talking about. Just to go through this life cycle of the project, and I'll take what Engineer Ahmed Al-Anezi had shared with us earlier this morning, and that is the field trip. Again, part of the suitability analysis that has been done is to use of the extensive field trips that the GKSA team has done over the past 2.5 years. And as we can see here is, again, extensive field trips and data collection on site. And using on the left-hand side here, you can see different layers, and we'll go through that in details. Another key thing that help standing on a solid ground is to know exactly where we are today. And that is what is the current, the rich and diverse vegetation, like we've seen colleagues throughout the day. But again, a key number is how many trees do we have now? How many shrubs? How many? What is the ground cover that we have now? Again, employing these geospatial technologies in data acquisition is a key as a start. Again, as shared earlier, there are key principles, 6 key principles that are the project to sustain this planting of 10 billion trees. This is a great ambition. One of them is a suitability modeling, enabling the suitability modeling, which we'll dive into here in the next few slides. As you can see, the geospatial technology, one of them is a geospatial portal. We used to give it 2 names, the backbone of the project and also the glue that puts all the pieces together. You can see basically 4 pieces here. It's a data acquisition, the geodatabase, which houses all of the data analysis on the right-hand side, and then presenting this, like my colleague here, engineer Ahmed Nami, was talking about earlier. We won't go through a lot of details here, but basically the suitability modeling, we start with, again, the 2-sided coin. Where is this national park? Where is urban areas? Where are the mangroves? Where are the areas? So we delineate the areas first, and then we say, okay, what are the criteria that we could use to selecting the suitability? A key thing to the success of alhamdulillah, this project was standardizing the efforts, like making a standardized effort that everybody can actually use it the same across different action zones and across different subject matter experts. And again, there was a suitability modeling memo that was defined and outlined, so that, again, it's a standard way of analyzing it. Again, there's about 50 subject matter experts that were part of this great project, great national project. Everybody has their opinions about a specific suitability criteria. So we've developed an app on the right-hand side here to allow the subject matter experts to put what are the criteria. Is it soil? Is it water? Is it slope? Is it elevation? And what is the importance of that layer? What you're looking at here on the left-hand side is obviously extensive list of these criteria. After we used this criteria from the subject matter experts, everybody in their subjective manner, again, there's the weights and criteria. So we use this data to comprehend this, and we've built also what we call the golden quadrant. What you see here is this matrix. On the left-hand side is the suitability, and then on the right-hand side is the water availability here. Obviously, we want the place where it's high suitable, but also high suitability. But we also did not forget to normalize this by socioeconomic factors, which is key to success of this. We'll skip through this very quickly, but basically what you're looking at here is how we delineated this specific action zone, the national parks, and we came up with this final area that has been delineated through even 2030. And then this is the area, again, this is the delineation and the layers that we've discussed. But each one of these layers, as you can see here, this is average rainfall over the kingdom within this action zone. So only the polygons, not the entire kingdom, but this action zone specifically, as you can see. Red areas, of course, low rainfall, and the blue is higher rainfall. Other areas, like other layers that we've used that the subject matter experts requested as an important factor in selecting what is the right plant in every specific location is aridity index. Again, a very high aridity index. Slope is another example. There's a very long list of that. We won't go through all of this, but this is part of the analysis. As you can see, there are 2 types of analyses that have been developed. And as you can see here on the main data view here, the main map, you can see all of these layers combined together with a statistical analysis to say which area has a specific score. And as you can see, red to green, low score to high score. We use this to take that and reclassify it from a geospatial concept and say, okay, out of all this, give me the number. What is the low-hanging fruit? Where do I best plant the trees right now? As you can see, the bluer or the bluest is in this particular action zone is where this is suitable. And again, this is the score that has been divided by this, as you can see, the histogram there of this geostatistical analysis. You can see the red, green, red, yellow, and green, where we actually say where the best locations are. And that's basically the output, and I wanted to share this with everybody. Thank you.
Thank you for such a thorough presentation. Now, I have a question for you, please, before I move on to Dr.
Yes,
or
please.
Mr. Ronald. Now, you mentioned the sustainability modeling, which is quite an important factor when it comes to
Yes.
what we're talking about. So what are the GIS approaches applied to support implementation activities, if you will?
Yes, and I'll probably think about that. My colleagues here that have heard this from me before, I think about it like a table that has 4 legs. One is any project. In a project life cycle, there's planning, there's design, there's construction, and there's operation and maintenance. The geospatial tools is, again, the glue that would carry this application throughout the life cycle of the project. So to implement, to actually plant trees and operate and maintain using remote sensing technologies, to monitor the health of a plant, geospatial tools is that backbone, the glue that would put all of these 4 pieces together that would help through implementation.
Lovely, thank you.
Thank you.
Mr. Ronald, the floor is yours if you want to start with your presentation, and then we'll move on to our questions.
The green one? Okay, thank you. Assalamu alaikum. Thank you very much for the opportunity. And I know we are against time, so I will try to go fast. So I will just share, a lot has been said today about soils, which is turba. So I will just try to go to the important parts, showing how soil health can contribute to achieve this ambitious program. Is this one, right? Okay, so we usually don't see the soil because the soil is down our feet, right? Technology sometimes.
It's supposed to make
Can
our lives
translate.
easier, right? But it doesn't.
Sometimes.
It's, I think, the small green button.
Yes, but it goes back.
Try the other button, please, Mr. Ronald. The small green one. There you go. Yes.
Okay. So soil is basically the interface between air and water, and if we want quality air and quality water, then we need to take care also about the soil. Soil provides multiple ecosystem services, okay? Many of them we cannot see because if I tell you nutrient cycling, you don't see, right? And maybe it can scare you, but it provides many services that can help us with the greening program. We heard about carbon a lot, and carbon is the flavor of these last years. And we need to understand that if we look at the global stock, soil by far has the highest number of carbon stock, and I'm talking about organic carbon, if compared with vegetation and the atmosphere. Yet, we didn't quantify, for instance, the soil in organic carbon stock that is mainly through calcium carbonate. And it's very important to know that if we degrade our soils, all this carbon plus other greenhouse gases are emitted. Soil is very important for climate change if we want to fight it. If we do the right things in managing soil sustainably, then we can mitigate, we can adapt to climate change, and we can build resilience. In the other side, if we degrade our soil, then we will release not only carbon, but also nitrous oxide, methane, and then all the nutrients that our soil has, etc. So the list can be long. A very important part is to understand that soil is not an inert or a dead material. It's full of life. If we talk about biodiversity, we always see animals and plants, but do you know that around 59% of the global biodiversity is in our soils? And the challenge that we have is that we know around 2% of this biodiversity in the soil. because you have plenty of bacteria, fungi, and nematodes, and many things. And if you want to learn about them, you need to use some techniques to sequence. And in this is the problem and can be the solution, because some of these microbes are good, some others can become pests, diseases, etc. So if we understand this, we can have the solutions to many of the problems that we face. And you know, and we know that water is one of the main challenging factor in the country, and soil can help us with storing, particularly rainwater. But for storing this rainwater, we need to have our soils ready to store it, like a sponge. But unfortunately, sometimes our soils are compacted or eroded, and with this, we lose 50% of the potential to store this rainwater. From a soil point of view, the main soil degradation problem in the kingdom is soil erosion by water, but particularly by wind. And you can see it. I took this picture when we were going to the field in the highway, and you can see easily how this sand is moving around. That is a clear, visible erosion. And the same here. This is a dam. Look at the color of the water. The water should be another color, not this one, right? This is showing you that this is full of soil that has been carried out by water from different parts of the watershed. If we see this field, you will see one species of shark that is not that welcome and not even palatable by animals, okay? But it is there. And if you see it, you will see that it created like a mound. This piece of vegetation has been protecting the soil. And if we measure, okay, the height of this small mound between two, we calculated and measured it around 30 centimeters. It means that we lost 30 centimeters of soil, okay, in this space.
That's interesting.
If we multiply this by the bulk density of the soil and we convert it into an area, we are talking about 156 tons of soil per hectare per year, which is, okay, maybe the calculation is not precise and you can say 100 tons. It still is a huge amount of soil that you lose. And you need to consider that for nature to create 1 centimeter of soils, you are talking about thousands of years. And in here, we are just losing it, okay? And there are different causes, many causes. One of them is overgrazing, of course, and the challenge here is that everybody wants to have vegetation, not only for making us happy to see it, but also animals need to be fed, and we need to find a way to put a solution. The solution to soil erosion is that we need to protect the soil, to cover it. How to cover it? By vegetation. So, yes, but if your soil is degraded because you lost the most rich part of your soil, which is the 30 centimeters that has all the nutrients, and then you lost the capacities to store water, it's a bit difficult to also allow vegetation to grow. So the two are interrelated. And we have these main soil factors that we need to overcome if we want to really grow vegetation. And definitely our dream is on how to make our soils healthier so that then we can contribute to this greening ambition. It's possible, it's doable, and we are trying to do this. And the first step towards it is to know our soils. We need to have detailed information about the potentials and the limitations of the soils around the kingdom so that we then can target very specific management practices that will allow us to overcome those challenges.
Lovely. Well,
Thank you.
You said that it is doable to have healthy soil. Now, I really want to know, how can we obtain healthy soil to have, a much easier greening process?
Okay, I visited some places where, for instance, for 2 consecutive years, the animals didn't enter this place, okay? It was somehow protected. And there you can see natural regeneration, particularly where you have 2 very important inputs. There was soil, some soil, because one of the challenges here is that we have many sandy soils, and in sandy soils it's very difficult to store water. All the water can go into the lower place, or it can become runoff if compacted, okay, and carry off by the flash floods. So if we have some soil to retain this moisture, and then you have more water for the plants, then you have natural regeneration, and we have seen it. So we need to try to replicate that concept, and we are trying to see how we can revert somehow these sandy soils by adding some organic matter. And we have heard today from many presentations that there are many materials that everybody wants to add to the soil, but we need to discover which one is safe, means free of pollutants, okay? Can be metals or can be also some microbes that are bad. It should be cost effective, and of course it should be giving us efficiency, because we need efficiency in the use of the water, but also in the use of the amendments to the soil.
Interesting. Thank you, Mr. Donald, for sharing.
Thank you.
Ronald, I'll get back to you, مهندس أحمد. تطرقت في إجابتك سابقا للذكاء الاصطناعي واستخدامات الذكاء الاصطناعي فيما يخص التشجير. لماذا هو مهم اليوم استخدام مثل هذه التقنيات في مشاريع الكبرى للتشجير؟
زي ما تعرفين يا أختي، الآن أعمال التشجير تكون مساحات كبيرة وبأعداد مهولة من الأشجار. متابعة الأعمال هذه
And to progress, to monitor the progress is in a certain area. For
اللي
example,
عندها مليون شجرة صعب الإنسان يجي ويعد واحدة واحدة كذا لين يخلصها. فالتقنية سمحت لنا أن نستخدم
technology has allowed us to leverage the benefits of this technology in order to monitor the progress and also study the soil moisture, as my dear colleague Dr. Ronald mentioned, as my colleagues also mentioned before in other sessions. We need to care for a seedling, and until it becomes a tree, it could be irrigated sufficiently, caring for this seed from the moment it's planted. We could use artificial intelligence and other technologies to watch and monitor the health of the soil, and a routine in monitoring and control is important. Technology has accelerated so fast, and we see amazing technologies. Sometimes we could see the difference between areas, and these colors that show us the areas, different areas, and we could reach to 255 different color scales that reflect different problems or indicate different algorithms that we have been able to cover vast landscapes and also quantities. So we have managed data.
There are other important things we notice in life. We see Saudi platforms that are really good at electronic platforms. We see the effort and the money and the resources spent on these platforms. these have a really influence on the economy of the country and Dr. Ahmed.
You now about the challenges you may have faced when using GIS sustainability modeling for tree plantation specifically.
You know, throughout the past, I don't know, 29 or 30 years of experience in this field and application of geospatial tools in environmental science in general, and specifically in you know, vegetative cover, is, and I will probably think about it like a tree. Like we plant a seed, if we don't water it, if we don't give it, you know, the agrochemicals that it would actually need, the fertilizers and all of that, then it dies. It doesn't continue. So the concept of sustainability in the suitability modeling is a key. And if we just put the data and we don't grow it, we don't convert the data to information, convert the information to decision making, that would actually allow decision makers to take informed decisions and reliable decisions based on dashboards and actual tools. I would also maybe share something here is, again, the technology has advanced quite a bit in the past few years. One of the applications that we've done in the past, but it needs to be integrated. So integrating all of these pieces like a puzzle, putting it together to get a very, very good and pretty picture, pretty and functional picture, not just pretty picture, is the agriculture, the water consumption of a tree. Is the tree actually using the right amount of water? And that helps in planning, that helps in the pipeline that Engineer Ahmed Al-Nami that was showing in the area. Is this pipe already sized good enough? Well, artificial intelligence can help, and again, the team and our team is ready to actually estimate using the remote sensing how much water is needed by each plant, each tree, at the right stage of life of the tree. So again, the continuity, the glue, the backbone of this data, not just build the database and just drop it. No, we just collected the data, we had a sustainable plan, just take it through the fruition of that seed, not just a seed in the ground.
Interesting. So to each challenge, there's a solution. We just need to be patient and find that solution.
Yep. And sustain and continue that solution.
Absolutely.
Yep.
Absolutely. And monitoring. And from that perspective, exactly, I'd like to move to Mr. Ronald, and perhaps I'll conclude and end with this question. Now, we've all agreed that soil health is very important and essential to the process. What are ways to monitor the soil's health and create that sustainability that we are talking about?
Sure. Well, what is important is to monitor soil health over time in order to understand if our actions and solutions are really working and improving. And for this, the first step is to have a good baseline, right? And then compare some functional properties. For instance, having an indicator of this sandinization, we will call, because you have a lot of sand all over, right? So if we are taking measures of planting more vegetation, in theory that has to reduce this movement, right? So we need to find a way to compare how was before and how is it now. And the same with other important properties like carbon, although for carbon you need quite a lot of time to see a difference, okay? There are some short time, and then there are others that you need more time to see. And for this, we are planning to establish the soil information system of the country that will have this monitoring capacity, so we will be able to know if what we are doing is right or not.
Lovely. Thank you so much, Mr. Ronald Vargas, for joining us today. Dr. Ahmed Salah and Engineer Ahmed Al-Nami, thank you so much for joining us in this session. It's so fruitful, and I loved and enjoyed this conversation with you. Thank you all, ladies and gentlemen, for joining us, and enjoy the remaining of your evening.